Hello, my name is Daniel, and this session is titled Power BI CI/CD with Tabular Editor. I work as a principal architect at a Danish consulting company called Capacity, and on this slide you can see my LinkedIn or Twitter tags if you'd like to get in touch. I'm a Microsoft Data Platform MVP, and I'm the author of Tabular Editor. So, why do we want to do DevOps, and why do we want to have CI/CD in particular? CI/CD is continuous integration, continuous deployment, and well, there are several reasons why this is a good idea. For example, having a backlog that we can use for project planning, estimation, and so on is a good thing to have whenever you're making anything really. Version control is also one of the disciplines of DevOps. It also helps us enforce best practices when we are developing code in order to ensure a process of integrating new code through pull requests with code reviews and so on. And most importantly, it's a process that once you have it implemented, it can save you a lot of time and ensure consistency with everything you do. So automating all of your builds, your testing, and your deployments. Tabular Editor only supports working with the tabular object model metadata of analysis services, tabular models, and Power BI datasets. It's not possible to author or edit any of the other types of Power BI artifacts, and therefore Tabular Editor only enables DevOps and CI/CD for Power BI datasets. In an enterprise environment, consider other solutions for the remaining artifacts. For example, you could use something like PowerShell scripts for migrating reports between environments using the Power BI REST APIs. I'm using Azure DevOps in this demo, as DevOps covers both Git for version control and Azure pipelines for CI/CD. But you could certainly use other kinds of version control software as well, and other CI/CD servers. You will of course need Tabular Editor for editing the actual dataset model metadata, and you will need the Power BI XMLA read-write endpoint, which requires dedicated capacity, so either Power BI Premium or Power BI Embedded SKUs. But of course, if you're not even using Power BI for your data model, but using SQL Server analysis services or Azure analysis services, then the techniques shown in this demo will apply to you as well. Lastly, you are going to need a service principal that has admin access to the Power BI workspace in which the dataset is going to be deployed. So, before embarking on the Power BI Dataset DevOps journey, there are a number of things you have to take into consideration. For example, how should your version control branching strategy look like? So this is typically dictated by the overall workflow of development. For example, how long does it take to get new features into production? How long time does it take to get them tested and signed off? Do you have a pre-production environment? How many developers work with the same solution at the same time? Do you have new features that should be delivered continuously or in periodic sprints? In this demo, I'm going to show a trunk-based branching strategy, which is kind of the simplest form of branching strategy that you can employ. You also need to consider what kind of policies that need to be in place for code integration. For example, should all code changes be linked to backlog items? Do all code changes require code reviews? And how are you going to merge code changes from feature branches or topic branches into your main development branches and so on? Specifically for Power BI datasets or analysis services tabular models, Tabular Editor provides some options for splitting the model metadata. So instead of working with one large JSON file, Tabular Editor can split all of those metadata into several smaller files, and there may be some considerations there in regards to exactly how this split should happen. Splitting into many smaller files is ideal, especially if you're using Git as a version control environment. You also need to decide whether you need a developer or sandbox instance, because, for example, if you want to allow multiple developers to work in parallel and test the impact on their code changes on actual data, then of course each developer will ideally need to deploy a dataset in a sandbox environment for each feature that they're working on. And if these models need to be refreshed with data, then there may be some cost considerations as well. If the changes that you make to your dataset often encompass adding new tables or columns, then you need to consider how this change should impact the model, because in that case you should probably think about integrating some kind of dataset refresh as part of the deployment pipeline. Otherwise you risk deploying a dataset which holds incomplete data, which may not be queryable after the deployment is complete. And of course you need to consider whether you want to have some kind of unit or integration testing going on as well. Now, traditionally unit testing code in a database is a tricky task, and in this case we consider Power BI Datasets or analysis services tabular models no different. They are also databases. But there are various techniques that you can employ for creating some kind of unit or integration testing. You can use Tabular Editor scripting, you can use Pester if you like to use PowerShell, NBI, and so on. So, one of the most important features of Tabular Editor for continuous integration, continuous deployment, is the Tabular Editor command line interface. This interface works well with command line tasks in Azure pipelines, but you can use it on any CI/CD server that supports executing Windows applications. The Tabular Editor command line interface can read model metadata from files or folders, so that would be from your Git code repository, and then it can perform many different tasks on these model metadata. For example, it can save the metadata to various formats, and it can run a best practice analysis and a schema check. You can even make small metadata adjustments. For example, if you have to specify some credentials as part of a connection string just prior to a deployment, that's certainly possible to do with Tabular Editor. And then of course Tabular Editor can deploy the model metadata through XMLA, either doing a full deployment or an incremental deployment where you retain some of the objects in the existing dataset, for example the partitions. This is useful in cases where you have some kind of incremental refresh policies specified on your dataset. So let's head over to the demo. So in this demo I want to show you end-to-end how to do continuous integration, continuous deployment on a Power BI dataset using Azure DevOps and Tabular Editor. The agenda for the demo looks more or less like this. First, we want to set up some prerequisites in Azure DevOps, some things we're going to need to get started. Then we will see how we can serialize a Power BI dataset, a data model, into a folder structure with Tabular Editor, and how we can add those metadata files to Git. Then we'll see how we set up the various pipelines we need in Azure DevOps. And we're going to need three different kinds of pipelines. We're going to need a validation pipeline, which is being executed every time someone submits a pull request. Then we're going to have a build pipeline, which will take all of the code in our integration branch and compile the code, so to speak, into an artifact. And then we will finally use the release pipeline in order to control the release of our build artifact into various environments, so dev, tests, and production. And then we will see how we can set up branch policies on our Git repository in Azure DevOps in order to ensure that the validation pipeline is automatically executed when a new pull request is submitted, and that the validation pipeline has to succeed before we can merge the pull request. All right. So the first thing we want to do is set up the Azure prerequisites, Azure DevOps prerequisites. So First of all, we are going to need to register a service principal. So that means if you don't have access to your Azure Active Directory, you will have to ask your Azure Active Directory admin to set up this service principal for you. So a service principal is the same as an app registration that needs to be created in Azure Active Directory, and this is basically for when we want the Azure DevOps build pipeline to make a deployment or to publish the data model dataset to our Power BI workspace. We need to somehow have you can think of it as a service account that is going to access the workspace for deploying the dataset. So here you can see I created a service principal called DevOps SP Easy Peasy Lemon Squeezy, and this is the one that we are then going to head over into the Power BI admin portal in order to make sure that so actually there's a setting here we need to specify first. So in the admin portal under tenant settings, we need to enable allowing service principals to use the Power BI APIs, because otherwise the service principal will not be able to access the workspace at all. Once we've done that, we head over to the workspace. So for example, here for my development workspace, I go into workspace access, and then under the access tab, I type the name of my service principal, and I give my service principal admin rights to the workspace. And once that's done, I can then set up a pipeline in Azure DevOps, which will use the service principal account in order to deploy content to this workspace. Of course, I need to repeat this step for any additional workspaces that my Azure DevOps pipeline is going to access. The last thing we need to do is to go into Azure DevOps and set up our project. So if we didn't already create an Azure DevOps project, we need to create a new project. If not, we just go into that project and make sure we have a Git repository where we can store our dataset source code. Next up, we want to use Tabular Editor in order to serialize our data model into a folder structure, which we can then add to the Git repository. So, in case we already created a data model in Power BI Desktop, all we need to do is go into Power BI Desktop and launch Tabular Editor through the External Tools ribbon. Now, once we have Tabular Editor open, for those of you who don't know what Tabular Editor can do, it lets us make quick changes to a data model in Power BI, changing measures, dragging and dropping measures between tables and display folders, creating new measures, setting properties on multiple measures at once, and so on. And it can also unlock advanced modeling features like calculation groups, perspectives, and even metadata translations. However, not all modeling features are supported when you're working on a model in Power BI Desktop. So basically what we're going to do now is we're going to disconnect the data model from the PBIX file, and that's when we store the dataset metadata into a folder structure. Now, you should be aware that this is a one-way street currently. So once we take out the data model metadata out of the PBIX file, there's unfortunately no way we can go back and create a PBIX file from this raw metadata. If you don't already have a PBIX file, you can also create a data model using Tabular Editor from scratch by going to the File and New Model option. And if it's going to be a data model that you're deploying to a Power BI Premium dataset or a SKU, then you just use the 1520 compatibility level. Otherwise, if you're deploying to Azure Analysis Services or SQL Server Analysis Services, you choose one of the corresponding compatibility levels for the environment that you are targeting. So going back to our model, what we wanted to do was we want to save this model into a folder structure. So we go to File and choose the Save to Folder option. We give our folder a name. In this case, I just call it Pass Demo. And then once the model has been saved, we can switch over to our favorite Git tool. I'm using the Team Explorer in Visual Studio, where I can inspect all of the files, all of the changes that were made to this folder on the right side of my screen. And now, since this is our initial commit to the Git repository, then it's not really that exciting, but later on when I make changes to this model, you'll be able to see how I can track the changes and show the differences between two files and so on. And at that point it should become apparent why it can be an advantage to have our data model split out into separate JSON files like this, instead of having everything in one big file, and especially considering that the PBIX file is not suitable for versioning in Git at all, since PBIX uses some kind of proprietary compression encoding format where you won't be able to make comparisons between different versions of the code. So that explains why it's an advantage to use this save to folder functionality to get our model metadata pulled out of the PBIX file, so that we can easily put it in version control. Provide a commit message and then commit and push your code to the Azure DevOps remote repository. Visual Studio will show that the code has been successfully committed. So we go back into Tabular Editor, and then we open the tabular model metadata from the folder from where we just saved it. This is equivalent to saying that now we're going to work in disconnected mode, and at this point we can close Power BI Desktop if we like. So now that we've loaded the model metadata from the folder structure, let's do a manual deployment to see that it actually works. So we go to the model menu and click on deploy, and then we put the URL of our Power BI workspace where we want to deploy the dataset. We type in a name. In this case I typed past demo manual deployment, and we just leave all the settings at their default values. Looks good. So let's hit the deploy button. It takes a couple of seconds, and finally we should see deployment succeeded. At this point, we can switch over to Power BI on the Power BI service, and inside of our workspace, we should see that we have the past demo manual deployment dataset in the workspace. And so at this point, we can also go to Azure DevOps, where we should be able to view the code that has been committed as well. So next up, we want to add a script to our code repository. We're going to need a script when we are running our build and validation pipelines later on. So we hit the ellipsis button, choose new file, and then we provide a name for the folder and the file name that we want to create. And then on the GitHub page for Tabular Editor, there's an article where you will find this script that we're going to need. This script is used to replace Power Query data sources inside of our dataset with legacy data sources, and this is needed in order for Tabular Editor to perform a so-called schema check, which is one of the checks that we're going to do during our build validation. So if you scroll down a little bit, there is an SQLN CLI version of this script. That's the one we're going to use. So we copy this script and paste it into the code editor in Azure DevOps, and then we optionally type a comment and then push the commit button. We are going to need one more script, so let's add that to the scripts folder. The name of the script should be replace data sources.csx. And then once again, if you follow the URL in the slide notes, this is a script also available on the GitHub wiki, which is used to replace the server names and database names encountered in the model metadata Power Query partitions. This is useful when we want to deploy the same model metadata to different environments, for example a development environment, test environment, production environment, where we want to specify different server or database names for each environment. Again, commit the script, type a comment, and this concludes the initial population of the Git repository with the model metadata and the scripts that we are going to need for our deployment pipelines. So the next part of the demo is about creating the pipelines that we are going to need to perform a validation, to create a build, and finally to release our solution. So the first pipeline we are going to create is our validation pipeline. This pipeline has the steps which will be executed every time a code change is made in order to verify that the code doesn't have any errors. So we go to the Pipelines tab in Azure DevOps and we click on Create a new pipeline. I prefer to use the classic editor for creating DevOps pipelines, but if you prefer you can create it using YAML as well. Set up the pipeline to use the Git repository. In our case it's the pass demo repository. And let's start with an empty job. Here we go. Okay, so this will be our validation pipeline. Pipelines in Azure DevOps can be triggered in various ways. This validation pipeline will be triggered every time someone creates a pull request. And we will have a policy that we are going to set up later on so that the pull request can only be completed if this pipeline has finished successfully. When you use the Azure Pipelines agent pool, as you can see here on this slide, we assume that all of the tasks on the pipeline can run in the cloud, meaning that your pipeline will only need to access resources that have a public endpoint, for example, such as the Power BI service, or maybe even something like Azure Analysis Services or Azure SQL databases and so on. However, if you do not have a public endpoint, so if you want to deploy a tabular data model onto an on-premises SQL server, for example, then what you need to do is to provide your own agent pool, which is basically installing some software provided by Azure DevOps on a machine somewhere within a network where it can reach the internet and also reach the resources that you want to deploy to. So the first task that we are going to need in our pipeline is a PowerShell task, which we will use to download Tabular Editor onto the build agent. Now, of course, if we had been using a self-hosted build agent, as I explained a moment ago, we could just pre-install Tabular Editor on that VM and it would always be available. But since we're using an Azure pipeline, so a Microsoft hosted build agent, then we are going to need our first task to download the tool that we're going to need for some of the subsequent tasks in this pipeline. So add a PowerShell task to the pipeline, give the task a name, add the script. This script can also be found on the GitHub page or in the notes for this slide deck. Next up, we are going to need a command line task, and this is the task that will actually execute Tabular Editor, since Tabular Editor has this command line interface that we can use. So we add a command line task, we give it a name, and then we specify the command that this task needs to execute. So the first command we have here is to run a Tabular Editor best practice analysis, and that is what we do with the A switch that you see here. And we use the T switch in order to instruct Tabular Editor to output the results of the best practice analysis into a TRX file, which uses the VS test unit test file format to output the results of the best practice analysis. Before moving on to the next task, we are going to need to add a couple of variables to our pipeline, specifically for storing some credentials and connection string information. So head over to the variable tab and then add, in this case, two variables, SQL username and SQL user password. We can click the padlock to indicate that a variable should be treated as sensitive. And while we're at it, let's also add the PBI connection string variable. This is the connection string that is going to be used when we want to perform a validation deployment to our Power BI workspace. And if you look at the slide notes, you will see what the full connection string should look like, but the connection string should include information about the service principal, application ID, tenant ID, and secret key. So going back to the tasks tab, we are going to add another command line task, and this task will perform the Tabular Editor schema check, which is a check that compares imported columns in the data model against the columns in the underlying data source. Now to perform this check, we need to execute the script that we added earlier to our repository, the set credentials for validation script, because Tabular Editor is not able to validate the Power Query, any Power Query data sources or partition queries in the data model. So we use this script which will convert the Power Query partitions to corresponding SQL query based partitions using a provider data source, and by specifying the command that you see on the screen here, we can execute the script with the S switch, and then once the script is executed, the SC switch will perform the actual schema check, and then finally the T switch will write the results of the schema check into another unit test file. Since our script requires a number of environment variables to be set, we also need to add these environment variables to the command line task. For the SQL server name and SQL database name, we just hardcode the values directly in our pipeline. And as you can see, for the SQL username and user password, we pass in the variables that we defined a few slides back. Lastly, we need a final command to actually perform a deployment, and this is what I call a validation deployment, where we use Tabular Editor to deploy the actual data model to the Power BI workspace. And the reason why it's a good idea to have a deployment step in our validation pipeline is because analysis services will so analysis services is the data engine running behind Power BI, and it will return an error message if we have any syntax or semantic errors in our DAX logic within our model metadata. So it's good to perform this empty deployment, and we can just name our dataset that we are deploying to whatever. In this case, we call it ECPC_validation. And this is just going to be an empty data set, so we will be deploying it to a development workspace just so we can get information about any errors. And again, using the T switch here, we can put the results from the deployment into a test file. If we wanted to do any additional unit testing, we could use other techniques like PowerShell. There's a library called Pester for PowerShell, which makes it easy to create unit tests. We could use NBI, or we could even use Tabular Editor scripts to run any additional tests. For example, to evaluate DAX queries against the model, comparing the results of these queries against the data source or something like that. And yeah, there are some options there, but that is outside the scope of this presentation. But this is where you would want to add additional unit tests if you had them. Finally, we are going to add a publish test results task to our pipeline, and this is where we collect all of the TRX test results files that were produced in the 3 Tabular Editor validation steps. and this task will make sure to publish these so that we can view the results of any tests directly through the Azure DevOps web interface. When we configure this task, we have to specify VS test as the test result format, because this is the format used by Tabular Editor. And we should also make sure that the files that we include, that we specify the correct pattern for the files that we want to include. And lastly, we should configure this task to run even if some of the previous tasks have failed, because by default, Tabular Editor is going to provide a non-zero exit code if, for example, the best practice analysis fails. And so in that case, we want to make sure that we still publish the test results. Next up, we save and queue our pipeline so that we can, so when we queue the pipeline, it will start to run. And so we can have a look at the test results. This is the interface for showing what a pipeline run looks like. We can see that this run was initiated by me and that it is currently running. If we click on agent job 1, we'll be taken over to the log view, where we can see the log outputted from each of the steps in the task. What we see here is the logs from when the best practice analyzer was executed. And we can see that we do have some rule violations, but the task itself did not fail. And this is by default. When Tabular Editor encounters a level 1 or a level 2 rule violation, it will not fail. It will only give a warning and then move on to the next task. However, these rules will show up as failed unit tests when we view the test results later on. This task performed the schema check, and since we don't really have any output here, it seems that all of the columns that are imported into our data model are in perfect alignment with the source columns in the model data source. Lastly, this is the output from the validation deployment. And we can see here from the output that we get some information about objects that are unprocessed. This is no surprise because I deployed a new dataset to my Power BI workspace, so it doesn't hold any data, and that is why we get this information here. If my dataset had included a measure with an invalid DAX expression, then I would be given this information here also as an error message. Going back to the pipeline run and clicking on the tests tab, we can view all the test results from all of the TRX files produced by Tabular Editor in one place. And we can see here that in fact for this run we actually did have some failed unit tests, and these were, as I mentioned earlier, the failed best practice analysis rules that we encountered. However, these are not critical, because if any one of these had been a severity level 3 best practice rule, then the best practice analysis task itself would have failed, causing the entire pipeline to fail. So in this case, we regard these as warnings that we do not want to block the actual validation pipeline. We do not want the validation pipeline to fail, so we will still allow the pull request to be completed if this pipeline had been triggered by a pull request. Now it's time to create the build pipeline, which is the one that will sort of compile all of our source code and scripts into an artifact that we can use for deployment. We don't have to run any unit tests as part of the build pipeline, as that was already taken care of by the validation pipeline. So this is just a way for us to have a pipeline which is very quick to run, which will produce the artifact that is needed later on. So the easiest way to create the build pipeline is to just clone the existing validation pipeline. We rename the newly cloned pipeline, so we call it parse demo build pipeline instead. and then we select all of the tasks that we don't need. In fact, the only task we still need here is the PowerShell task that is downloading Tabular Editor. Then we add a new command line task. We rename it, and we specify the command that uses Tabular Editor to compile the model metadata into a single file. We use the .bim extension, which is the normal extension used for tabular model metadata files in analysis services. Also note how we store the BIM file in this build.artifact staging directory. So this variable is a special Azure DevOps pipeline variable that puts that points to a folder which has been cleared prior to execution of the pipeline, and this folder will then hold all of the files that we want to include in our build artifact. Next up, add a copy files activity. We are going to need this in order to copy over the scripts from the Git source folder over to the artifact staging directory as well. So we set this up this way. We point to the scripts folder within our repository. We specify that we want to have all the CSX files in this folder, and then we specify the target folder, again using the build.artifact staging directory variable. Lastly, we are going to need two publish pipeline artifacts, one for the PBI dataset and one for our scripts. So go ahead and add a publish pipeline artifact task to the pipeline. Change the name to publish PBI dataset artifact and provide build.artifact staging directory /PBI dataset as the file or directory path from where the artifact should be loaded, and use PBI dataset as the artifact name. Add another publish pipeline artifact task to the pipeline and name this one publish scripts artifacts. And again specify the file or directory that this time pointing to the scripts folder where all our scripts have been copied, and name the artifact scripts. Then go over to the triggers tab, and this is where we want to specify that this pipeline should be triggered automatically. So put a check mark in the enable continuous integration checkbox. And then under branch filters, we use a filter that specifies that we want to trigger this pipeline every time a commit is made to any Git branch which is prefixed by release /. Now save and queue the build pipeline to check that it works. Wait for the pipeline to complete. It should not take more than 30 or 40 seconds. And then once it is completed, you click on the one published, one consumed link here under the related headline. This is in order to view the produced artifacts from the build. And expanding the artifact folders, we can then see all of our files here as part of the two artifacts, PBI dataset and scripts. So generally, this is everything that is needed later on when we want to release and deploy our model metadata into the Power BI workspace. Of course, for a real end-to-end BI solution, you could imagine having additional artifacts in here. For example, if you wanted to deploy a SQL-based data warehouse, you would probably have something like a DAC file created with SQL Server data tools. You could also imagine having stuff like SSIS packages or data factory pipelines, whatever other things you'd consider as being part of your BI solution. The last pipeline we are going to create in this demo is our release pipeline. And the purpose of the release pipeline is to manage the deployment of the solution to one or more environments or stages, as they are called. So this is the pipeline that will actually perform the solution deployment. So first off, before we create the actual pipeline, we are going to create a set of variable groups which are going to hold various information which is specific to the various environments that we are going to deploy to. So first off, let's go to the Library tab and create a new variable group. We give the variable group a name, so we start off with our PBI dev variables. And while it is possible to link variable groups to an Azure Key Vault, we are not going to do that here. We will just be populating the variable group with variables that we put directly into the interface. The first variable we are adding will be the PBI connection string variable. This is similar to the one we used over in our validation pipeline when we performed the validation deployment. So keep in mind this needs to be a connection string that holds all of the credentials of our service principal so that Azure DevOps can connect and perform the deployment to the Power BI workspace. Make sure to click the little padlock icon to hide the sensitive data in this string. Add two more variables, one for the SQL Server name and the SQL database name. So these the values of these variables are going to be replaced inside the Power Query partitions of our dataset just prior to deploying it. This way we can have datasets published to different workspaces using different connections, such that our dataset in the development workspace will be refreshed with data from a development SQL database, and then we can have different SQL servers or SQL databases for other environments like test and production. Finally, save the variable group, and then the easiest option for creating additional variable groups is to just clone this variable group, one for test and one for production. And then go into each of these and correct the variables. So that would be both the PBI connection string and in our case also the server name. We do the same thing for a production variable group so that we end up with 3 different variable groups like you see here. And then we head over to the Releases tab where we will now create our release pipeline. So first off, we start with an empty job. Once again, I'm not a fan of YAML, so I prefer to creating my release pipelines using the classic approach. We change the name of the first stage to development. And we will be creating the test and production stages later by cloning the development stage once we have all of the tasks we need in the development stage. Next, we need to add an artifact to the release pipeline. So this is basically the binary code or the source code, the package that we want to bring into this release for deployment. So in this case, this would be the output of our build pipeline that we created earlier. So we specify the past demo build pipeline as our source and use the default latest version. And then we can provide an alias for the source, and we can just use _drop. This will be the name of a folder when our release pipelines are executing, where all of the files from the artifact are being dropped. Next up, we go to the Variables tab because we have to link our variable group that we created before to the development stage. So go to the Variable Groups tab and then click on Link Variable Group. Then you will be presented with all 3 variable groups that we created before. For now, just pick up the PBI dev variables and make sure that it is scoped to the dev stage. Now, one more note about these variable groups is that they can be linked from an Azure Key Vault. So instead of putting all of these secrets and credentials and so on into variable groups that has to be maintained inside Azure DevOps, it is possible to connect these variable groups to an Azure Key Vault that has all of these secrets instead. Click on the link button, and then we can see that the 3 variables, PBI connection string, SQL database name, and SQL server name, are now available as variables that we can refer inside our pipeline tasks. So going back to the pipeline, let's click on the link here where it says one job, one task. And this brings up a familiar user interface that looks just like the one we had when we created the build and validation pipelines. And in fact, we need a lot of the same tasks in here. So The first task we will need is a PowerShell task, which is the same one we used before for downloading Tabular Editor to the build agent. So go ahead and add that. Configure the task in the same way as we did before for the build and validation pipelines. And then also make sure to specify a working directory on the PowerShell task, because this makes it easier for us when we ensure that Tabular Editor is downloaded and unpacked in the same location as our artifact files. We can use shorter path names later on when we are referring to the files. Next up, we add a command line task. This will be the task that uses Tabular Editor to actually deploy the model metadata to the Power BI dataset in the workspace. Now configure this command line task. Write out the script that will call Tabular Editor in order to perform the deployment. So we can see the first argument here after Tabular Editor is the path of the deploy.bim file that we created in our build pipeline. And we use the S switch in order to execute the replace data sources script, which we created earlier. This script is responsible for setting all of the SQL server names and database names within each partition of the data model. And finally, we use the D switch to indicate that Tabular Editor should perform a deployment towards the Power BI workspace specified by the PBI connection string variable and using the credentials that are embedded in that variable. We use the name pass for the dataset that we're going to deploy, and then we specify an O to indicate that Tabular Editor is allowed to override an existing dataset in the same workspace with the same name. The C switch specifies that Tabular Editor is allowed to override any pre-existing connections in this dataset. The V switch and the E and the W switch are just standard switches that we always use to have Tabular Editor behave in a nice way when integrating it in an Azure DevOps pipeline. So this has to do with how log messages are formatted in the output and how Tabular Editor reacts to any errors that occur during deployment. Next up, go to environment variables for the task and pass in the two pipeline variables for the SQL server name and SQL database name. It's better to pass in the variables instead of hard coding the names for the server and database, because this way we can just, when we create the stages for test and production, we don't have to modify this task, but we can just link the test and production stages to different variable groups, and then the correct version of the variable value will be inserted into an environment variable when the Tabular Editor command line is executed. Also set the working directory to the drop folder like we did for the PowerShell script, because this allows us to use the relative paths when referring to the deploy.bim file and the replace data sources CSX file in our command. Now we head back to the pipeline tab in order to clone our dev stage, once for test and once for the production stages that we are going to need. So click the clone button and repeat for both test and production, specifying the names that we want to use for each of these stages. And then we have an option of setting pre or post deployment conditions on each stage. These conditions determine when the next stage in the pipeline is going to execute. I prefer to put pre-deployment approvals on the test and production stage, so that I will receive an email and a notification that I need to approve the deployment before the pipeline can proceed with deployment to test and production. But of course you can set this up any way you like. Lastly, let's head back to the variables tab, changing the scope of our PBI dev variable group so that it is linked only to the dev stage. And let's also link our variable groups for test and production, scoping them to their corresponding stages. And that's it. Now save the release pipeline and click on the create release button, and then we will create our first release using this pipeline. When we create a release, just make sure that the version of the artifact that we are using corresponds to the latest version of the artifact produced by the build pipeline. In my case, this is version 48. Click create, and then we will see that the dev stage immediately begins deployment. Since the only thing that we're deploying in this pipeline is a Power BI dataset, it should complete within 30 or 40 seconds. And in this case, Tabular Editor reports a warning. Since this is the first time I'm deploying this dataset, we have unprocessed objects, so we have tables in the dataset that do not contain any data. So we get this warning, and the deployment pipeline reports that the dev stage only partially succeeded. Because it only partially succeeded, we will not be allowed to proceed with deployment to the next stage, the test stage in this case. So we should switch over to Power BI and then ensure that in the Power BI workspace that we can now see the new dataset, which is the parse dataset that we have just deployed. If we try to refresh, we may get an error that credentials are missing. In that case, we can go into the settings for the dataset. And in here, we can edit the credentials for the dataset. Now, of course, we could also use the Power BI REST API, make a call to the Power BI REST API as part of our deployment pipeline in order to set these credentials. Specifically, these are the username and password that the Power BI dataset needs to use in order to connect to the SQL server. But since these credentials will not be overwritten on future deployments, I can simply edit the credentials once in here. And then once I'm done with that, I will trigger a refresh, manual refresh inside of Power BI to make sure that the dataset has been populated with data. And then when I'm done with the refresh, I go back to Azure DevOps and I click the redeploy button in order to force Azure DevOps to deploy the solution once again to the dev stage. This time, Tabular Editor should not report any unprocessed objects, so the dev stage should now show as succeeded, and this should allow us to proceed with the next stage. Since we set up pre-deployment approval, I will need to explicitly approve that the deployment can continue here. So I click the approve button, and I can provide a comment if I like. Clicking approve once again, we can now see that deployment to the test environment should now be in progress. And finally, after completing the deployment to all three stages, our release should look like this. And we can now see that our dataset has been successfully deployed to all three Power BI workspaces. And thus we have demonstrated how to use Azure DevOps for fully automated deployment of Power BI datasets to the Power BI service. The final thing we need in this demo is to set up our branch policies that takes care of how code is integrated when developers are working on the solution. So the first thing we want to do is to go back to the GitHub repository on the branches tab. And then on the master branch, we click the ellipsis button and go to branch policies. Here we get an overview of all of the various branch policies that we can apply. For example, you can require a minimum number of reviewers, or you can require that work items always needs to be linked to a pull request. At a minimum, I recommend requiring work items be linked to pull requests, that comments should always be resolved, and that merge types be limited to only allow squash merges, because this keeps a clean history, which is very nice when we're using the trunk-based branching strategy. We also need to add a new build policy under build validation. Specifically, we want to run our validation pipeline that we created earlier in the demo. And here we can apply a filter so that this pipeline is only executed when changes are made to the PBI dataset folder or any files beneath that folder. And lastly, if we like, we can also add a reviewer policy so that, for example, certain people get notified when pull requests impact specific parts of the code base. Once the branch policy is set up, we are ready to go. So let's see what the development workflow would now look like. So first of all, let's say we have this developer who has this new task to create a gross margin calculation in the model. Well, the developer should start by creating a branch directly on this task, because then the task would already be linked to the new code branch. Name the branch feature and then /initials / the name of the feature you are working on. And then for a simple change such as this, the developer doesn't even need to open Tabular Editor or any other tool. If the developer is comfortable just using the code interface inside Azure DevOps, well, then that is perfectly acceptable. So in this case, we just simply add a new file to represent the new measure with the new gross margin calculation. And we just supply the JSON code for this file directly in the editor inside Azure DevOps. You can see here the expression for calculating gross margin is gross profit divided by sales amount. And then we just directly create a pull request once this file has been committed. We can provide a title and a description for the pull request. Once that is done and we have assured that the work item is linked, we click create. And then the pull request will automatically trigger the validation pipeline. If there are any code reviewers assigned to the pull request, they would also need to approve the pull request before it could be completed. But for now, the developer just needs to wait for the validation pipeline to complete. But in the meantime, it's possible to set up auto-completion so that the pull request will automatically get completed once all of the checks have passed. Simultaneously, another developer is tasked with cleaning up some format strings on the existing measures in the model. And this developer prefers to use Tabular Editor to do that. So they select the measures in the model and then they apply the new format string. They save the model metadata back to the folder structure. They can review the changes in the Visual Studio Team Explorer. And once they commit and push the code to Azure DevOps, they will also be able to review the pull request that they have made. This holds the same information about exactly what has been changed. And finally, after both pull requests have been merged, we can now see the resulting integrated code in the master branch, even though both of these developers were working simultaneously on the metadata. Just as an example, imagine we had a third developer working at the same time, who deleted one of the measures in the model, in this case the internet gross profit, thinking this measure was no longer needed. Well, thanks to the validation pipeline that we have on our pull request, this developer is going to see this error during the execution of the validation pipeline. So the pull request will not be able to be completed until this error is fixed one way or the other. So this developer has to go back to the drawing board to figure out what's wrong. Going back to the master branch, we are now ready to create our release that integrates the changes made by the two successful pull requests. So we create a new release branch off of the master branch. It's also possible to cherry pick individual commits from the master branch in cases where we wanted to avoid, for example, one of the intermediate commits that were made. So we can sort of cherry pick exactly what code changes are going to come into our release. Once the release branch is created, we can see that our build pipeline is automatically triggered. And when the build pipeline has finished, we can go ahead and create a release right off that build pipeline run. So to use the artifact produced by that build pipeline. And here we just need to make sure that we are running the correct release pipeline and that we are targeting all of the stages in our solution. And then we just wait for the release to be completed. And all the time we can go to the releases page to track exactly which version of the code has been released to which environment. So you can see in this case we just need to deploy to production. This is pending approval. But once that has been completed, we now have the final code changes integrated, and everything has been deployed to the production environment, where we can see now both the new gross margin calculation, and at the same time we can view the updated format strings for the sales amount. So that's it. Now we have seen how we can use Azure DevOps to set up a completely automated continuous integration and continuous deployment pipeline for our Power BI datasets. The next steps from here would be to include our SQL database projects, if we had that, our ETL pipelines, reports, dashboards, and other Power BI artifacts, for example, using the Power BI API or the PowerShell commandlets, or we may even use the new Power BI deployment pipelines, which we have a link to here in this slide. And of course, for completion, we should probably also consider including unit tests for our PBI datasets and integration tests for the full solution. Once all of that is completed, we can finally rest easy and we will have no more deployment headaches. These are some links to some of the references used throughout this demo. There's also a link to a YouTube video that I created for Power BI Tips, which has a longer and more live demo where you can view these things in real time. So go ahead and give it a shot and see what you think about Azure DevOps deployment of Power BI datasets. Thank you very much. I will stick around for the next 15 minutes to answer any follow-up questions that you may have. Remember to explore everything PAS has to offer throughout the whole year. There are local user groups around the world, exclusive training and networking opportunities, and lastly, don't forget to submit your session evaluations. Your feedback is very important to us. Thank you.